So ladies and gentlemen, I present to you the derivatives of the 6 inverse trigonometric functions. Just notice as you're writing these down for the first time, now that we know the chain rule, we have derivative rules that are given with the chain rule built in. So if I were just going to take the derivative of the inverse sine of x with respect to x, now my variable matches what I'm taking the derivative with respect to, I would just have 1 over the square root of 1 minus x squared. And I wouldn't need this times du dx. So pause the video there and finish writing down those derivative formula. Some things to notice: the derivatives of co-functions, co-inverse functions, are just opposites. So the derivative of inverse cosine of u is the opposite of, its negative derivative of the inverse sine of u. And that's true for all 3 pairs of functions. Alright, let's try some of these examples. Alright, the first example on your page, we want the derivative with respect to x of inverse sine of x squared. So remember that our formulas now, our derivative formulas, are given with the chain rule built in. So I have to figure out what's standing in for u for this function. So I think u is supposed to be whatever's getting its inverse sine taken, which means that u is equal to x squared. Which means du dx, when I need it, is going to be 2x. So here I go. I want the derivative of inverse sine of x squared. According to my formula, that's 1 over the square root of 1 minus u squared. But what's standing in for u? It's x squared. U needs to get squared. I'm going to multiply by du dx, which I said is 2x. You could leave your answer like that on the free response section, but notice it's likely to get simplified, especially in the multiple choice section. So you can simplify that as 2x over the square root of 1 minus x to the 4th. Here I have a particle moving along the x-axis. I know its position function, x of t, is inverse tangent of square root of t. I want to know the velocity of the function when time equals 16. So I can find the velocity function. That's the derivative position. So v of t is going to equal, how do I take the derivative of inverse tangent? Well, I have to figure out what's getting inverse tangented. I'm going to call that u. So in this case, u is square root of t. Du dt is 1 over 2 times the square root of t. That's 1/2 t to the negative 1/2. It's just simplified or rewritten using radicals. So I'm going to have the derivative is 1 over 1 plus u squared. Well, what was u? What was getting inverse tangented? It was square root of t. And I'm going to multiply by the derivative of u, which is 1 over 2 times the square root of t. So v of t, I could simplify. That's 1 over 1 plus the square root of t squared is just t. I'm going to multiply by 1 over 2 square root of t. Do not waste your time trying to get a common denominator or simplifying. That answer is perfect. We'll answer the final question, which is what is v of 16? That's going to be 1 over 1 plus 16 is 17 times 1 over 2 times the square root of 16, which is 4. So 1 over 17 times 8.